In this video, I am going to explain Dalton's atomic theory. Now, who was Dalton? Dalton was a teacher in England and he had discovered this theory. That is why, just to honor his name, this theory has been given Dalton's atomic theory, and this is the beginning of systematic chemistry at that time. He was a really great man to discover this theory. He said that, or he better stated that, all matter is made up of very tiny particles called atoms. Okay? So all forms of matter, it is solid, liquid or gas, and elements, compounds or mixture are made up of very small particles called atoms. Okay. Atom is a Greek word, means indivisible or uncut. Okay, Greek word means uncut or indivisible. So his first statement was that all matter is made up of very tiny particles called atom. Second, atoms are indivisible, particles which cannot be created or destroyed in a chemical reaction. Yes, whenever a chemical reaction occurs, atoms take part in that chemical reaction. So there is exchange of atoms. Okay, exchange of atoms in a chemical reaction. There is exchange of atoms in a chemical reaction. Yes. For example, suppose if oxygen and hydrogen react with each other, okay, they combine together to form water. So here the atoms combine themselves to make a new product in a chemical reaction. That's right. Now, third, atoms of a given elements are identical in mass and chemical properties. Okay, atoms of a given element are identical in mass and chemical properties. Yes, this was disproved. It's because later on, when isotopes were discovered, this statement was disproved. Also, that atom is indivisible it was also disproved, because later on it was found that atom itself is made up of three basic particles called electrons, protons and neutrons. It's okay. So when the isotopes were discovered, it was found that an element contains atoms which are different in mass. They do have the same chemical properties, all right, but they do have different masses. For example, hydrogen. Hydrogen has mass 1, mass 2 and mass 3. Mass 1 is called protium, mass having 2 is called deuterium, and mass having 3 is called tritium. Okay, so the same hydrogen element contains 3 different kinds of atoms having different masses. They do have all the same chemical properties, but their masses are different. Now the fourth one, atoms are different elements, have different masses and chemical properties. He said that atoms of different elements have different masses and chemical properties. It's okay. This is next one, atoms combine in the ratio of a small whole number to form compounds. Yes, ratio is whole number. So atoms of elements combine in the ratio of whole numbers to produce a large number of compound atom. of a new substance. The compound atoms of a particular substance are identical in all properties and differ from those of their substances. It means that suppose if water is made up of hydrogen and oxygen, so when hydrogen and oxygen react with each other, they form water. The property of hydrogen that it burns itself and the property of oxygen that it helps in burning has completely lost in water. Water neither burns nor helps combustion, but contrary to all these, water extinguishes fire, isn't it? Yes. And now the next one, it is the relative number and the kind of atoms are constant in a given compound. It is here. Yes. The simple one is the carbon dioxide. So carbon dioxide has CO2. So whatever the source of collection of carbon dioxide, it is sure that the number of carbon atom is 1 and oxygen atom is 2 in carbon dioxide. Okay, he mean to say this, it is here. Means the number of relative atoms and the kinds of atoms are constant in a given compound. Yes. For example, one more example, sodium chloride. Sodium chloride is a salt, bench salt, or you can say table salt. This salt is used in our kitchen. So it is made up of 1 atom of sodium and 1 atom of chloride. So that is sodium chloride. So whatever the source of preparation of sodium chloride, okay, it will contain 1 atom of sodium and 1 atom of chlorine. It is sure, 100% sure it is. So, okay. Now I am just going to relate you the drawbacks of atomic theories of Dalton. Okay, he had at that time, okay, this electron microscope and some sophisticated instruments were not discovered, but when they were discovered later on, so Dalton's atomic theory, certain things in Dalton's atomic theory was disproved. So according to Dalton's atomic theory, an atom is the smallest, okay, discrete and indivisible particle of matter. But this is not now. However, in modern researchers have shown that an atom is divisible. It is truly, okay, it is divisible, it is here now. Okay, atoms contains electrons, protons and neutrons, these 3 basic particles. Okay, hydrogen does not contain, okay, in protium, hydrogen does not contain neutron, but these 3 particles are present in almost all kind of atoms. Okay, so this was disproved. Second, Dalton's theory says that all atoms of an element have exactly the same mass. I explained to you that. Okay, the discovery of isotopes indicated that all atoms of the same elements are not perfectly identical. At least they differ in their masses, yes. They do have the same chemical property, but they differ in their masses. This is the second drawback. Third, atoms of the same elements having different masses are called isotopes, that we know. So according to Dalton's atomic theory, the atoms of different elements should have different masses. Okay, it is however known that even atoms of different elements have equal masses. For example, calcium and argon. Calcium and argon, they have the masses 40 U. Just me rectify it is here. Argon, it is a yes. Argon has 40 U and calcium also 40 U. They have the same. They are the same masses, but they are the atoms of the different elements.